The next topic I'm going to talk about is a auto transformer. Auto transformer is a single winding transformer. It is a single winding transformer which transfer energy by both induction as well as conduction. So what is induction and conduction? If you look at a single phase transformer, these two windings are isolated. Okay, there is no electrical connection between these two. So whatever energy is transferred from primary to secondary, it's all induction. So in a two winding ordinary regular transformer, energy is transferred through induction principle. Okay, where it comes to the auto transformer, what we're going to do, we're going to combine these two coils, connect them together. Okay, now look at this. This is going to act like a single coil, and here is your primary V1, here is your secondary V2. Okay, so this is a single winding transformer. Now it can step up or step down the input voltage. So here, if you look at this picture, here your V2 must be larger than V1, and if you reverse it, your V1 is larger than going to be V2. So basically, if I have it like this, okay, this is my step, this is step down. So here is your V2, V1. Okay, this is step down. So similar to ordinary transformers, we have step up and step down transformers. Okay, the main application of the auto transformer is to increase or decrease a small amount of voltage like 12.8 kV to 13.2 kV or 13.2 kV to 12.8 kV. So to increase or decrease the voltage, a small amount of voltage, we usually use the auto transformer. The simple example I'm going to talk about, say if you look at any transmission line, usually this transmission line, say the voltage here is 13.2 kV. Okay, say this generator is generating 13.2 kV, where, and you are using the transmission line. Okay, so here this transmission line is very short line, like 1 kilometer or 2 kilometer. So basically we know that this line will have some resistance R equal to rho L by A and reactance. For sure the voltage is going to drop. Say the voltage is dropping to 12.8 kV. So 400 volts is dropped across this. So what we can do, we can use a auto transformer. So here is an auto transformer. Here we are giving 12.8 kV. Now it will give you 13.2 kV. 13.2 kV. So I'm stepping up at 12.8 kV into 13.2 kV. So this is a step up auto transformer. That's one of the simple application. Another simple application you might have not seen, previously we used to have the chargers, 9 volt, 12 volt, like 6 volt, something like that. It's a simple same charger, but all you need to do is rotate your knob to 6 volt, 9 volt, 12 volt, so you can get that different voltage. Okay, that is also nothing but an auto transformer. We're going to give AC supply. Okay, it will step it down to 6 volt or 9 volt or 12 volt, and there is another mechanism to convert that step down AC voltage into DC. So that's the main purpose of auto transformer. Now when it comes to the advantages, less copper is required for the auto transformer. The copper required for auto transformer is less. Efficiency is higher than two winding transformer because part of the energy transformation is via conductance or conduction. Okay, energy transfer through conduction. And the third one is smaller in size and low cost. Third one is smaller in size and low cost compared to the two winding transformer. Next one is less leakage reactance and better voltage regulation. Voltage regulation is nothing but V no load minus V full load over V full load. Okay, voltage regulation. Usually this is in percent, so times 100 when it comes to the percentage. So if the voltage regulation is 0, that's a good transformer. That means the voltage drop. So when it is no load, say the voltage is 12.8 volts or say 13.2 kV. When it comes to full load, say the voltage becomes 12.8 because the remaining 400 volts is drop inside the transformer. I'm talking about inside the transformer. Okay, then to 13.2 kV minus 12.8 kV divided by 12.8 kV, that will give you the voltage regulation. Here in this case, so if I use that number 13.2 minus 12.8 over 12.8, I end up with 8.05%. That is the voltage regulation. 8% is too much. That's a too much loss. That's a too much loss inside the transformer. We want to have this voltage regulation as close to 0 as possible. Okay, so the voltage regulation tells us that how much voltage we are losing inside the transformer. So with the auto transformer, we are saying this voltage regulation is better. So it's better than 8% or close to 0%. So 0% is excellent. Okay, and 100% is the worst case. So you're not getting anything. That's what it tells you. Okay, really bad. Okay. Now the disadvantages with this auto transformer, I mean, you see so many advantages, then why are we not widely using it? Because of low impedance, high short circuit currents. So that indicates that, I mean, since we are using only one coil, impedance of the coil is very small, and at the same time there is no isolation. So if you look at here, the two windings are electrically connected, right? The two windings are electrically connected. So if something goes wrong here, that will escalate on the primary side and it will damage the equipment on the other side. Okay, so that's the main disadvantage with auto transformer. That is the reason we don't use widely the auto transformer. Okay, so because of that's low impedance is one reason. Another one is no electrical isolation between the primary and secondary. That's the major reason we don't use it very often. Since one section of the winding is common, and if something goes wrong with the low voltage winding, then all the high voltage will appear across the load and it will destroy the appliance. So that's another disadvantage. Now I'm going to draw the picture and show you what it is and what are the parameters. Actually, I'm going to talk about it here. So here is a step down auto transformer. The number of turns are same as single phase regular transformer. Okay, so ideal case, I'm going to draw two lines like that. So V1 is the primary voltage. It is a step down auto transformer, by the way. V2 secondary voltage. I1 is the primary current. I2 is the secondary current. Okay, IC is the common coil current. So I1 is coming there, it's going to split at this point. IC is going down and I2 is going in this direction. Okay, so the IC is the common current. N1 number of turns of the second series coil. So here this is called series coil because this coil is series to the common coil, and N2 is number of turns on the common coil. So when it comes to the transformer ratio, N equal to, it is always V2 over V1. Always the transformer ratio is V2 over V1. I have V2 equal to number of turns. I have only N2 number of turns on the secondary side. When it comes to V1, the total number of turns are N1 plus N2. So for step down auto transformer, this is the transformer ratio. Okay, so I mean, don't blindly follow. For step down transformer, it's always N2 or N1 plus N2. I mean, compare here which terminals or which number of turns are representing the secondary winding, how many number of turns are representing primary winding. Based on that, you can tell. So here the next one is step up transformer. Okay, step up auto transformer. So if you look at here, N equal to V2 over V1. So how many number of turns are there on the secondary side? I see N2 plus N1. N1 plus N2. On the primary side, I have only N1. Okay, this is the transformer ratio. Okay, and same thing here also. I1 equal to, I1 is going to split, I2 is going up, and I see common current is going down. So I1 equal to I2 plus IC. That's the, and rating of auto transformer is V1 times I1, V2 times I2. I will stop this video here. In the next video, I'm going to explain how a regular transformer can be transformed into an auto transformer. Thank you.